Okay, so I've got my site boundary drawn with the site view that has my satellite image showing, and then a copy of that view where I've turned the satellite image off so we can just see our AutoCAD line work, and of course most importantly we've got the spot levels there. And so I want to put a Toposurface in using these heights, and at this point you need to make a decision whether you're going to work with relative or absolute levels. Now I'm just going to click on the Toposurface tool to show you. If you click on the Massing and Site tab, you'll see that if you haven't used the Toposurface tool very much. Okay, all the site tools are there under Massing and Site. If you go to Toposurface, you'll see then that you have an option there for absolute elevation. Now there is a way to work with relative elevations or relative levels, but it's not really worth it. So if you see anything about working with relative levels in Revit, it's probably worth avoiding that and just working with absolute levels. Even though they'll still be called RLs, RL means reduced level. Essentially we're working with raw AHD levels. So AHD, do you know what that means? Australian Height Datum. Yep, good. So that's basically sea level, and so that's a good basis for your heights. What you'll then need to think about though is how your levels are going to work with that. And if it's high, in this case it's 40 metres above sea level of AHD, that means we're going to have 40 metres of empty space below our site. That's actually not that bad. 40 metres is workable. When it gets up into the hundreds, if you're working at a higher elevation, then you maybe can think about using relative or reduced levels. But in this case, it's not that bad. So that's the first thing. Just think about whether you're going to work with absolute levels or not, and it is best if you can work with absolute levels. And I haven't clicked on anything else after clicking on Toposurface. It's gone to the Place Point option, and I'm going to leave it on that. If you click somewhere else, then you might need to just click on that again so that you can type in your elevations. Alright, so I'm zooming out a bit so that I can see the site boundary. Then I'm going to zoom in there. It's a bit hard to see, but we should have crosses where the point locations are. But sometimes the point display comes in from AutoCAD in an unusual way, and yeah. Oh yeah, bingo, yeah, good eyes. Yep, so that's it. So we can see them, but yeah, it's just the colours really that are making it hard. So then again, these are in metres, so we've got to convert that to millimetres, and it will be 42,400, and then I can click on my point. If I type in the next type, 42,180, I still won't see a surface. But then if I do a third point, so this is 42090, once we do that third point, then we're going to get a surface. And if you're not sure still how the Toposurface tool works, basically it's like join the dots. So it's not drawing in a sequential way. If you click points going around the edge of your site, and maybe just to prove this I'll do that. So I've got a point up here, which is 42480. Okay, so it's joined those points together, and this one here has remained inside, so it's not going diagonally from here to here to here, the way it would maybe if you're drawing a polyline or a line in Revit or AutoCAD. So if I then go over to do a point in the middle, God, those crosses are going to destroy my eyes, but here we go. So 42660. Okay, so it's connected to that point, and I'll do one down below. So what's this? 41230. You can see it doesn't really matter the order that you do the points. And okay, so then I will do one all the way over the other side. So here, 43740. Oh no, that's for something else. Watch out for that. When you get levels that seem really different to the things around them, it's because they're for risers or things that are above the natural ground level. So I might just leave that one for now and we'll find another one. So 39730, I'll use that one. Okay, so now I'm going to do a point all the way up here. So that's a bad one. Let's do this one. We'll go this one, really. So 41460. Okay, so notice how it's just completely bypassed this point. That's now in the middle. So essentially what I'm saying is that you can never really define the edge in a simple way, especially if it needs to go in and out. So if you ever need to do that, say if you're doing a coastline or something like that, then what you need to do is make the topo surface first and then come back and cut it using split surface if you need an irregular edge. But the thing you need to realise about topo surfaces is that the outline doesn't really matter. So if it's got an unusual shape, and it will usually just end up being a big rectangle, so going to the outside of my topography or the surface that I'm trying to model, if I do a point all the way up here, and here I don't even need to get it exactly in the right spot because it's not on the site. We're never going to build up here. Okay, and then I'll do another point. Well, I don't even know the heights down here, so let's just find one maybe over here. So 38270. And then I'll just do some other points that are right on the outside. 39110, about here somewhere. And then another one right up here somewhere. So 40790. Okay, now the first thing there is that you can see it's covering most of the drawing now. So do you know the easy way of making it see-through? So you all know this one. Yeah, wireframe, exactly. So you just make it wireframe. It's the easy way to make it see-through. And so I can go and add in all those points inside. And I'll show you there's some tricks for working out the heights here. If you don't have levels, we can try and work that out later. But really what I wanted to show you is that when I finish that surface, looking back in the original site view maybe, we don't want that funny shape to show on our drawings. But all we do is crop it. So I might keep that site view there, but I'll duplicate it. May as well do it with detailing, even though there isn't much detailing. And then I'll rename it. And have you been giving your views for print certain names, like site print or something like that? Yep. So that's not a bad way to set things up. Okay, so this is a view we'll use for printing. That's a good thing that you've been doing. It's really good practice. And then with my, she missed that, I've just unhidden the crop region. And we can easily crop that so it's got a nice rectangular edge. And it doesn't matter that the topo surface has an irregular edge to the boundary or to its sides, because we're not going to see that, or other people aren't going to see that. So don't worry about the edge of your topo surface. That's where a lot of people get stuck, trying to make it follow a certain shape. It's going to have an unusual shape or an unusual edge, but you can easily work around that. And you can also do what I've just done, which is start with just a few points, finish your surface, and just see roughly how it looks. And I can see there, even though I haven't put much detail in, I can get a pretty good idea of the slope there. It does the contours, of course, as well. So with a site like this, even though it does have a reasonable slope, because of the scale, it's quite hard at first to appreciate that in 3D, and it'll look fairly flat. But as I add more detail, of course, I will get a better idea. But then another thing, let's look at this 3D view. I quickly made a 3D view because I'm assuming you all know how to do that, clicking on the house. I'm sure you've done that a million times at the top. And then do you know how to make that create new views? So when you click on the house, it creates a certain kind of 3D view. Do you know what that sort of view is called technically? It's not a perspective. So it's a 3D view, not a perspective view. So what's the other type of 3D view it could be? Something metric? Not far off actually. Isometric. Isometric is good. If you're thinking that way, that's the right idea. This is an isometric. If I click on the corner of my cube, that's a true isometric. But because I teach this stuff, I'm just fussy about the terminology. Isometric means equal angles. So that's why this is an isometric, because we have equal angles between the corners of my cube there. They're all 120 degrees. So that's an isometric. If you've ever heard, maybe heard the other angles, 30, 30, 60. That's a common way of describing an isometric, because looking at the cube here, from the horizon line, it will be 30 degrees to this axis, and then another 60 degrees to the vertical axis. So that's why when you're drawing by hand, you will set those angles up. But then thinking about the full 360, it is 120 degrees between those main axes, the two angles here and then the vertical. So that's ISO essentially means equal. That's where the term comes from. So then if you orbit, those angles are no longer going to be equal. But it's not a perspective view, and so the other kind of view is an axonometric view. So an axonometric is one you might have heard of, which is similar to an isometric, but it can be any angle as long as you've got a vertical axis. So that's what makes it an axonometric, the fact that you've got a vertical axis. So these are all axonometric views. And you use that house button to make your 3D views, or your axonometric views. On the View tab, this button does the same thing. But then after you've made the first view, click on that button again. It's not going to make a new one. It'll just keep taking you back to that view. So what I was saying is, how do you make that create new views? There's a bit of a trick. I've always thought this is a strange thing with Revit. You've got to give that view a different name. Just call it something else. If I right click there, that's the default name, 3D with the parentheses, curly brackets. If you right click there and just rename it, so let's call it Site Cutaway. Okay, so now, because I don't have any views with that default name, if I click on the house, it will make a new view, a new axonometric view. It's just the way Revit is. Now, there's nothing to stop you duplicating those views. That's another way of making new axonometric views. But sometimes you just want to get a new view with the original default settings. And that's the only way, by just making sure you rename the view with that name, 3D with the brackets, and then you can always get your default view back. So that's the first thing, just getting an axonometric view. And then also just wanted to show you that with a section box, we all use section boxes. Yeah, good. One of the best things about Revit, ArchiCAD. Has ArchiCAD got this yet? I don't think it does. It's one of these things, I've always wondered why ArchiCAD doesn't have it. ArchiCAD's got that, the selection, viewing your 3D selection and everything, that's good. But they don't have an equivalent to this, which I've never really understood. So anyhow, one of the best things about Revit, having that section box option on with your axo views. So there's my section box. It's coming a bit flat because I don't have very much, but I can drag it down a bit. Oops, sorry. Just being careful to get the right arrow. So I'll just drag it down a bit. I'm also going to drag it up the top, right up, because my building's going to be fairly high. So I want to have room for that. And now comes the interesting part. I'm going to drag the sides away, or sorry, the sides towards the Toposurface. And what do you know? They like to customize things in here. So people have customized things and it's showing a little bit differently. Oh no, it isn't. It's just my screen, sorry. It's okay. So here, I'm just making sure it cuts my boundary, and it's hard to see until you zoom in, but there you can see it. We've got the earth hatch. And so as soon as you cut your site, you're going to see that that ground being cut, or that you're going to see the hatch pattern where it's cut. But if it's not being cut, if I show you in the other view, it's going to show as a flat surface. So there we are, so that's not being cut. If I zoom in, you'll see it's just a flat surface. And that has its uses as well. When you're working, it's good sometimes to be able to see underneath the ground and work out what's happening. But usually when you're showing, especially if you're showing other people, you want the ground to be cut and showing with a hatch pattern for that. So I've just put it in on the sides, and that can also help for you to read the slope. So you can see there, because it's being cut, I can see quite clearly that slope there, measured against the bottom. One thing you can't show in the 3D views is boundary. So if you want to see the boundary, you've got to put in a physical object, usually a wall or something like that, or a fence, so that you can see the outline of your, if you want to see the outline of your site in 3D, you can do that. But I'll show you something else you can do as well when we look at subregions. So, you know, you can hide those as well. You can just right click, like anything else, hide in view elements. And then if you want to adjust it, you don't need to unhide it. You can just click on the light bulb and adjust it while you're in that reveal mode. If you don't know that one, that's really handy. So I can just change it, even though it's hidden, and then go back to normal mode to see the result. Okay, so then back to the survey, and I can select my Toposurface and then add in as many points as I can get in the time I've got. So back to edit surface, and so you might focus on the points that are within the boundaries, and then also maybe surrounding it, particularly on the footpath there, and maybe some of the road nearby. But then all the points, you know, up here where you have that the road across, you know, across the street from the site. There's a lot of detail there, but you're probably not going to need that level of detail. So I'd probably only put a couple of points there, and that'd be enough to set the height for that area, because it's not as important. But definitely within the site itself, you should try to put maybe all of the points there. So I can just go back to place point and continue, of course, adding in points. There we are. And you'll know if you get it wrong. This is why I often will just finish it. You might put an extra 0 in or something like that. And you can usually tell straight away, because in plan even sometimes it will be obvious, but sometimes if it, I mean, I've made it 10 times higher than it should be, but you'll definitely see in a 3D view if you get points that are out like that. It stands out fairly obviously, and you can always go back and edit that. So I'll give you a bit of time to maybe start your Toposurface, and then we can have a look at doing the subregions and other things to divide up your roads and things.